Hello, I'm Ryan Baker, and this is Big Data in Education, and this is the week on advanced data sources. We'll be starting our discussion with text mining. I call this lecture Text Mining Part 1 because it's the non-foundation model part. A little less fancy than the newest stuff, but still very useful. Text mining is an area that's related to a lot of areas: discourse processing, computational linguistics, natural language processing. Now, text mining is very different from the types of interaction data and course data I've discussed throughout the rest of the class, which is why I've kind of focused on that, and now I'm discussing this here separately. A lot of text mining these days comes down to you throw an encoder at it, like BERT, or the Universal Sentence Encoder, and then you run it through a classical machine learning algorithm. Or you give it to a large language model, a foundation model, and you do prompt engineering. That's next lecture. In this lecture, I'm going to discuss classic approaches, which are often still very useful. An important note about text mining versus other types of data is that different stuff works. Even besides foundation models, which are very domain-specific, different methods are effective for text mining than for interaction data. And stuff that works poorly in interaction data works great in text mining, like latent semantic analysis. More on that in a second. Like support vector machines. I had a colleague who was teaching his analytics class, and a colleague went to him and said, "Oh, you're teaching support vector machines. That's so quaint." But they still have a place in this area. And again, foundation models. Stuff that works great in interaction data is often less relevant in text mining. There's some interesting attributes of textual data that causes this. One of them is really high dimensionality. Many words in a corpus of data, and multiple levels of analysis that look very different from each other, from individual phonemes and graphemes to entire books. And those multiple levels of hierarchy have been an interesting challenge for the development of models that sometimes have to operate on multiple levels at once, which is one of the hallmarks and one of the powers of some of the contemporary foundation models. The approaches we'll be talking about today will be more typically at one grain size. A lot can be successfully done at the simple level of whether individual words are seen, and a classic and still popular algorithm for this is called latent semantic analysis. Latent semantic analysis represents utterances or paragraphs as a row, and each column is a word that can be present, 1, or absent, 0. So you've got, your rows are your utterances or paragraphs, your columns are the words in them, individual words. And then it conducts the SVD algorithm, a matrix factorization algorithm that's conceptually related to factor analysis and, for that matter, non-negative matrix factorization from last week. And it uses SVD to find the structure. And it doesn't look at the syntax of the text, just what words are present, though it does consider the co-occurrence of words across large corpuses. Now, these analyses can also be conducted using not just individual words, but pairs of words in order called bigrams, or triplets of words in order called trigrams. Take, for example, the sentence, "Colorless green ideas sleep furiously." The bigrams in that sentence are colorless green, green ideas, ideas sleep, sleep furiously. And the trigrams are colorless green ideas sleep, ideas sleep furiously. And indeed, colorless green ideas really do sleep furiously. One toolkit that you can consider using for this is LightSide, a toolkit that supports turning utterances into unigrams, bigrams, and trigrams, as well as more powerful feature extraction methods, and then runs your dataset through a range of machine learning algorithms. Another approach is to reduce specific words to semantic categories, such as sports or business or time, prior to the analysis. And this allows easier categorization of types of utterances that's less dependent on the presence of specific words when synonyms might be relevant. And two popular toolkits for this are Luke, the American one, and W-Matrix, the British one. Another type of tool can provide what are called coherence metrics, a modern, updated version of reading level metrics such as Fleisch-Kincaid. And this indicates how hard a text is to read, and tools for this include cometrics and Taco. There's also tools to detect lexical sophistication, how complex or advanced a text and the words in it are. And there are tools for this, including Tails, which incidentally includes many other measures as well, including measures of cohesion, and also TAMI, which provides measures of morphological complexity. Tools also exist for syntactic complexity, how complex or advanced the grammatical features in a text are, including the L2 synthetic complexity analyzer. Another broad area of analysis of these things is sentiment analysis, assessing emotion or attitude typically in terms of positive or negative, unlike some of the affect detectors we talked about earlier in this class. There are many, many tools for this. Some people use Luke, some people use Vader. In education, Seance is sometimes used. And so as you can see, there's a wide variety of tools, and they're still being actively developed for non-foundation model analysis of the linguistic properties of text that can be embedded into classifiers and other analyses. In our next lecture, we're going to discuss the other big area of text mining, foundation models, aka large language models, and we'll also discuss other types of foundation models as well.